Grade 11s, we're doing 6.3, graphing to solve systems of linear inequalities. Systems means more than one inequality. Inequality means we have things like greater than or less than, equal to, things like that. What it asks here is what conclusions can be made about the system of linear inequalities graphed below. So we have, first of all, we have green shaded. Green shaded means it's continuous. It means we're dealing with all green numbers. We have solid green lines, so that means that we have something like greater than or equal to, less than or equal to. We're including the boundary. So what we're going to do is we're going to try to get the graphs of the boundaries. Here's one boundary here, this nice straight line. So any horizontal line is y equals. We're going to start with equal and then work to the inequality. Y equals, no matter what point on this line, y always equals -2. So now we have to decide the region shaded. Looks like we're shaded above. The reason I know we didn't shade below is this part's missing. We've chosen all those values that are bigger than -2. So we're going to say this is the line of all y greater than or equal to -2. Next, we're going to look at the next line. Yeah, solid green is going to have an equals to, like this one does. What I see, first of all, when I look at this, is that there is a y-intercept. There's this point right here. And we know that y equals mx plus b is the form of a line. We look at this y-intercept, and we can see that that y-intercept is 3. So instead of b, we're going to put number 3. Now I'm going to look at slope. I'm going to start this point, and I'm going to move to the next nice point. There's a really nice point right there. And it looks like I have to move, I have to rise -2, and I have to run 1. I rose -2, and I ran 1. And that could further be simplified to just be -2. We don't need to have that one there. Okay, so that's the equation of the boundary, but we don't want an equation, we want an inequality. So are we talking about all the points to the right or to the left? Are we talking about everything out here or everything out here? And it looks like we're talking about over here. That's what's been shaded in. So what we're really trying to do is we're trying to figure out that these points here all satisfy that. The easiest point to look at is 0, 0. I'm going to sub in 0, 0. So if I have 0 on this side, I have -2 times 0 plus 3. Well, that just simplifies to 3. So what's the relationship between 0 and 3? What symbol would make the most sense? And that's this symbol. So that is the equation of this inequality. And that is the conclusions we can make. We also said that they were all real because of what was shaded in. We have a problem here. A company makes 2 types of boats on different assembly lines: aluminum fishing boats and fiberglass bow riders. When both assembly lines are running at full capacity, a maximum of 20 boats can be made. The demand for fiberglass boats is greater than the demand for aluminum boats, so the company makes at least 5 more fiberglass boats than aluminum boats. What combination should they make? First of all, am I talking, is this continuous, and can any number be an answer? Can we have 15.732 boats? No, so we're only talking about whole numbers. We're not even talking about negative, just whole numbers. Okay? We're only going to do whole numbers here. Let's do a let statement. I should have done that before. Let A equal number of aluminum boats, and B be the number of F be the number of the long day, F be the number of fiberglass boats. Now what we need to do is we need to make some inequalities. So when the assembly lines are full, maximum of 20. So A plus F maximum means that we have less than or greater than. a maximum of 20. We could have 19, we could have 16, we can't have 24. Okay? The demand for fiberglass throat, the demand is greater than the demand for aluminum. So fiberglass is more than aluminum. So the company makes 5 more fiberglass than each aluminum. So if aluminum had 12, fiberglass has at least 17. They could also 25. They could have anything more. So what we're saying is aluminum's on this side, fiberglass is on that side. We're saying that we had to add 5 to get there. We had to add at least 5 more. So it is at least that much. It's less than or equal to. Okay? Now what we need to do is we need to take these and we need to graph them. What's down here? So I'm going to graph this guy first. What I'm going to do is I'm going to do x and y-intercepts, or a and f intercepts. I'm going to first of all let a be 0. 0 plus f is less than or equal to 20. F, and I'm going to pretend for a second that it's an equality to do this. F is equal to 20. So the point I got when I put 0 in for a, I got 20 for f. That's one of my points. Okay? Now I'm going to do the same thing, only let f be 0. A plus 0 is equal to 20. A equals 20. So my other point is 20 and 0. So remember we said that this is only whole numbers, it's discrete. So we're not going to draw a line, rather we're going to do a stipple, a green stipple. So we said when our first point here, when a is equal to 0, f is equal to 20. So we have a point there. Our second point we said when a is equal to 20, f is equal to 0. And that is going to be a line that we draw. So we're going to nice stipple in a line there. Like that. Okay. Now, are we talking about this region or that region? And of course, we would be colored in orange. How awful of me. The color in orange. Are we talking about the point above or below? Well, I always start with 0. I like to put my 0 in. Is 0 plus 0 less than or equal to 20? You better believe it is. So we're talking about everything below this. So it's like I would shade that in orange. All of that in orange. Okay? Now what I'm going to do is I'm going to do the same thing for my other equation. I'm going to somehow try and graph this right here. I'm going to try my x and y intercepts again. So again, I'm going to let a be 0. 0 plus 5 is less than, or oops, remember we do equals then, is equal to f. So 5 is equal to f. I said when a is 0, f is 5. Okay. And now I'm going to let my f be 0. So a plus 5 equals 0. A is equal to -5. So my other point is at -5 and 0. Wait a second, there is no -5 because we're not even talking about that. So I can't even plot this one on my graph. What I'm going to do is I'm going to try and choose a different point because I need 2 points. So I said my first point was at 0 and 5. My first point is here. And then of course we're going to be doing green stipple again. So the green up there. And then I want to know where the graph goes when I get to, say, number 10 or 15. So let's try subbing in when we get to 15. So our equation is a plus f equals 20. We're going to let a be 10. So we're going to go 10 plus 5 is equal to f. So we subbed in the value 10. It's going to spit out 15 equals f. So we're going to point at 10 and 15. 10 and 15. Okay, so we're going to do a nice dotted line along there. Okay, so now what I'm asking, am I going to shade in orange everything up here or everything down there? my awful scribble. There we go. Okay, so first of all, I'm going to test the point 0, 0. So that would be everything below. I'm going to test 0, 0, and I'm going to see what happens. 0 plus 5 is less than or equal to 0. Is 5 less than or equal to 0? Heck no. So I'm actually talking about this region above. So I would shade in this region. Okay? So where does that intersect? Where are we talking about where both of these inequalities intersect? Well, we're talking only about, and I wish I could erase this. So we're talking only about this region right in here. That is where these two inequalities intersect. To be perfectly correct, we would actually put green stipple on all the points. And what this means is any point I can choose in here is going to satisfy both of the inequalities. So to be correct, we do all these dots. So I'm going to pick a dot. I'm going to pick a dot right here. That point is the point 2 and 12. And I'm saying that if I sold 2 aluminum bolts and 12 fiberglass, I would be within my parameters, be in what I wanted. Oops. And let's double check that here. A plus 5. Okay. So I'm saying 2 and 12 satisfies this. Well, is 2 plus 12 less than or equal to 20? Is 14 less than or equal to 20? Yep. Well, is 2 plus, because remember A value is 2, is 2 plus 5 less than or equal to, our F value is 12? Is 7 less than or equal to 12? Yeah. So any of these green points included in this region are solutions to this system, are the number of aluminum and fiberglass bolts that can be made with the constraints that we were given. Okay, a couple things to talk about. Okay, a couple of key ideas. When graphing a system of linear inequalities, the boundaries of the solution region may or may not be included depending on the types of linear inequalities. So depending on if we have those equal signs underneath. Most systems of linear inequalities representing real-world situations are restricted to the first quadrant because the values of the variables in the system must be positive. So what I'm saying is when we're actually talking about physical things like votes for people, we can't do negatives, we can't do halves. Okay? Any point in the solution region for a system is a valid solution, but some solutions may make more sense than others depending on the context of the problem. You can validate a possible solution from the solution region by checking to see if it satisfies each linear inequality in the system. For example, to check if 2, 2 is the solution, we have these two inequalities. What we do is we sub in on the left-hand side, x plus y equals 1. So we sub in, we said x was 2, y is 2, 2 plus 2 is 4. And then we did the right-hand side is 1. Well, is 4 greater than or equal to 1? You bet. Now we're doing the second inequality here. We're subbing in 2, 2. So the left-hand side is always 2. The right-hand side is x minus 2y. 2 minus 2 times 2. 2 minus 4 is negative 2. Is 2 greater than negative 2? You bet. So we have validated that. We use an open dot to show that an intersection of points on a system's boundary is excluded from the solution set. An intersection point is excluded when a dashed line intersects either a dashed or solid. Use a solid dot to show that the intersection is included. This occurs when they're both solid. So there's examples of this on page 316. It might be valuable. Make a note that that's on 316. You guys have been given your practice questions. You need to give those a try.